All right. In the review packet from Friday, finishing it up, when we're multiplying through, we're going to add exponents on our variables, but you multiply the coefficients. You multiply the numbers that are out in front. So when I'm doing this, this is negative 2 times 3. Okay? Yep, negative 6. Add my exponents, so it'd be x squared. And then I go and I do it with the next one. Negative, yep, times negative is a plus 8. Yep. And then x to the 1 plus 2 is x to the third. And I can't put those together because they have different exponents. They're different terms. And that's going to be the same for any of these. Even on one like 49 where I have to do it twice. So on 49, remember I got my ones here, I'm going to distribute to those first two things that are in parentheses. 2 times 3 is 6, and I don't have any other a's, so I'll just put a, or I could put a to the first if I wanted to. Absolutely. 2 times 4 is 8. 1 plus 1 makes it a squared. But I'm not quite done here because I see, another set of parentheses. So I've got a negative 4a, or I can put the little first on there. And then again, it's a negative 4. So negative 4 times negative 3 is positive 12. Now this time there's one more difference. I don't see any other a squareds, and I like to write them in order from greatest to least. Now, do I have to on these? No. But I notice, perfect, and good check on making sure that you're watching for signs. Just because I'm combining like terms doesn't mean I'm going up. 6 minus 4 would be 2a, and then I have 1. Ah. Good catch. So sometimes there is more to these than just, combining the terms and not paying attention to signs, which I almost didn't do. Now, if they throw an extra variable in here on you, don't let that get you either. Okay, we know there's ones on all of these. So when I go to distribute, I've got 3 times 4 is 12. X to the second, because I have x and x, I add their exponents, and I've got my y. And then I do it again to the second one. 21x, or I can put x to the first. And since I have y's in both places, I add their exponents. These, now I know they both have x and y, right, but I can't do it because their exponents are the same. So I'm done. Okay. So add your exponents, multiply your coefficients. And again, some of the directions and helps will be on here.
Wait, why can't you put it together?
Because these have to be identical. These both have to either have x squared and y squared. My variables and their exponents have to be the same.
Oh.
And if there's any little difference, I can't do it. And so also, like I've said, your notes are free reign on these too, so just something to remind you of. Now the equation, I'm going to go past 52 for right now. I want to hit some of the bigger ones here. Still doing some distributing here. So 3x plus 18. And one of the biggest things I've noticed when we do quizzes even is that you're real good at remembering that 3 multiplies to the first term, but it multiplies to both. So you've got to make sure it gets to both of those. And here, this is like a negative 1 going through. In other words, it's just going to change my signs. So I have a negative 1x and a negative 4. Okay, we don't multiply anything times the 18. It's not directly hooked to a quantity, to a set of parentheses. So now, this is just me. I would combine the like terms next. The simpler this is before we really start it, the better it's going to be. 3 minus 1 is 2x. 18 minus 4 is 14. And now I just solve it like I would any old two-step equation. My first job is to get x by itself. And then just divide by 2. So don't over-complicate things. Just keep taking it one step at a time. For a lot of you, no, it's not something you're going to get done in one step and boom, but it's something we definitely can work out. When I go to multiply, oh, yes, sir. So what we're going to do, I'm going to head down to 56 next. And what we're going to do here is, some of you are still very comfortable just using the lines and kind of working that through to multiply. And some of you have taken a little bit of a liking to box. So, as we get down here to 56, I'm going to just show the box one more time here, but I'll also show this one just using my lines so you can see that it works both ways. Doesn't matter along which edge I put each set of parentheses. You know, if you put your 2x plus 5 along the top and 3x minus 1 along the edge, that's okay. It'll get you the same answer. So then when I go to fill in the box, it's the same rules that I was using up top. Multiply the numbers in front, multiply the coefficients, and add the exponents. 6x squared. I was going to let her roll. Minus 2x plus 15x and a negative 5. Once I fill the box, if I start in the upper left corner, my like terms will always be in that next diagonal. So 15 minus 2 is 13x. And there's no other constant term. So I just put my minus 5. So on any of these, we're just going to box them out. Or some of you, if you're comfortable, can just do, you know, first 3x and 2x. That was where the 6x squared came from. 3x times 5 is 15x. Negative 1 times 2 is negative 2x. And negative 1 times 5 is negative 5. And you make the little dude with this smiley face, okay? Either one of those work. Whichever one you're more comfortable with.
Hey, which one is in?
You can. It will be for points, so if you get to a point where it's done and ready to go, absolutely it can come in. So, let's see.
I have iPad.
Oh, geez. Okay, I'll make sure the test gets down. All right, let's see here. Now, here's one we haven't played with in a while. Okay, 59. Now, this is not as simple as just taking this and distributing it to both of those and saying, I'm done. Remember, squared means I have 2 of these. And since I have 2 of them, I have to FOIL it out or I have to box it out. So, I guess I didn't need to make my box quite that huge, but it's all right. And again, here, I'm just going to fill in my box. X squared minus 6x minus 6x and a plus 36. Because again, I'm multiplying to fill the box. And once I've got it filled, start with that upper left corner. Negative 6 and negative 6 is negative 12x. Notice I didn't mess with the exponents. Okay, because once the box is full, we're just combining like terms. No more multiplying. So if I had just distributed up here, I'd have lost that minus 12x in the middle and I'd have gotten the wrong answer. Don't want the wrong answer. So that's a route to go there. And then 62. Now some of you might be comfortable with distribute, 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 distribute. To me, that's too many lines. And the box that we use can change on us if we need it to any size we want. So here I've got 2 terms by 3 terms. I can make that happen. Okay, absolutely. My first box, 1 plus 2 gives me 2x to the 3rd. Here I've got a positive 2. Add my exponents. Yep, x squared. Negative 18x, and then I just start up again. Plus 3x squared, nothing real fancy there. Plus 3x, and negative 27. And again, this is the nice thing about using the box. If I start in the upper left corner, okay, there's my first term. And each of those diagonals, 3 plus 2 is 5x squared. Again, no more messing with exponents at this point. My x's are together, 3 and negative 18. I'd still owe somebody 15 if I was thinking about it like money. And then minus 27. So a problem that looks really big and bad, nasty, and ugly, I'm just using the same idea that I did before, just a couple extra boxes to fill in. And that's the same way 61 would work. Now we get to the stuff that we were a little more recently working on. So as we move down here a bit. All right, growth and decay. Reminder, when I'm doing growth and decay, that's the form that I'm looking at, but what we're really looking at right here is the b value. If b is greater than 1, we're looking at growth. If b is between 0 and 1, we're looking at decay. So don't get fooled by the other numbers sitting on the outside. That'd be my initial value, but that doesn't mess with my growth and decay at all. So all I'm going to be looking at is to see if that number is bigger than 1 or not. If it is, we got some growth. And I could even punch this in on the calculator and physically look at it if I wasn't sure. If I wanted to, I could just go here and say, okay, and again, my exponent button, my caret's over here, and I can physically look at it. Oh, it's going up to the right. It's growth. Okay? That's an option I have. 0.7 is less than 1, so that's going to be decay. And then, yeah, this one, if you weren't sure, if you're like, oops, let me out of here. So this would be like negative 3 to the 1.25x. 1.25 is still bigger than 1. Okay, so it's growth.
Mr. Harty, are you doing it? Checking to see if the last number is bigger than 3?
I'm just checking to see if, let me get this out of the way, if the number in here is bigger than 1 or less than. If it's bigger than 1, it's growth. If it's not bigger than 1, it's decay. And then when we get to the graphing part, yep, we know for sure, we know this one is growth and this one's decay just by looking at that. So we know this one should be going up to the right, and this one should be coming down if we've done it right. So let's check this out. So let's get back into our y equals. Or I could do this, and I'll show you how to do it individually too, if you're like, yeah, this whole pressing all these buttons thing is not my deal. So 2 times 2 to the x would look like this. Now let's take a quick peek to see if it looks right. Oh yeah, that looks right. So if I hit second and graph, Oh yeah, there's that table. And basically we take any whole number that we see and we're going to plot it. So like for instance here, so I've got negative 1, 1. I've got 0, 2. I've got 1, 4. And I'm just going to plot anything that'll fit. 2, 8, 3, 16. And plot my points. If I didn't remember that, how to get that all punched in, I always, if I wanted to, and we've talked about this before, I always could just punch in my formula, but then I just plug in numbers. So like 2 times 2 to the first. So like for instance, I'd have 0, 2, 1, 4, and you're like, oh, they're the same points we just got out of the chart. Exactly. So just because one method might not work for you doesn't mean another one may not. So if you don't want to mess with the whole graphing function, because tomorrow again we've got that in the notes, but if you come up and say, now how do I put this in the calculator again? I'm not telling you. Because you either need that or you need to kind of play with this a little bit. Because, oops, why'd I shrink that? Because when I get to my other one, with decay, again, it's just y equals, and I type what I see. And again, the caret button is my exponent, and that x is what's right next to alpha here. All right, let's see if we can see the picture here first. Yep, that's coming down. That's good. So I start looking at the numbers, and I'm like, okay, there's a whole number. So negative 1, positive 16, 0, 12, 1, 9. And you start to notice that my numbers kind of start getting funky decimaled here. So I'm just going to do a couple more, and I'm going to kind of estimate where they're at here. And I'm just going to see, yeah, they just kind of keep going down, 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 down here. So I'll get that drawn in. But I knew ahead of time what it should look like because I knew it was decay. And I'll be paying somewhat attention to your dots, so you can't just be like, oh, it should be growth, I'm just going to scribble something. Yeah, no. I'm still going to be looking for certain points, sort of like the points I have on here right now. So do be aware that that's going to be something that we're looking at. Let's see, I think, yes. Okay, so on the back here now, for the following exponential functions, create an equation, y equals a times bx, and find the requested answers. Okay, just a reminder. A is my initial value, what I start with. It can be food, it can be money, it can be all sorts of things. And then my b value is 1 plus the percent if something's increasing, and 1 minus the percent if something's decreasing. And everything's got to be in its decimal form. So we're just going to set up equations right now. We'll come back and find the answers in a minute, but I want to get us on a roll just with this part. So all right, Mr. H has 512 Jolly Ranchers at the start of the week, but he has half of them stolen each day. How many Jolly Ranchers will he have at the end of the week? Okay, what's my A value? What am I starting with? 512. Okay, so y equals 512. If I'm having some of them stolen each day, am I increasing or decreasing? Decreasing. Decreasing by what percent? Yep. Decreasing by half would be 50%. As a decimal, what does 50% look like? 0.5. So 1 minus 0.5. And normally we put to the x here, but I want a specific date. After 5 days. So x is going to be my time. So what I'll end up doing is taking my calculator, getting back into regular old math mode here, and typing this in. I don't need to go to the y equals thing because I just want one value. And then my exponent is going to be 5. Whoops, after I put the caret in. No, not that way. Ouch. By the end of the week, I started with 512. I have 16 left. That would suck. But that's how the setup of all of these is going to work. 19. Josh has got $2,000 in his bank account, decides to invest in a surefire business that will earn him 14% interest per year. How much money will he have in 10 years? A lot. Well, let's see how much it's going to be here. All right, we're starting with 2,000. Increase or decrease this time? Increase. Now, my 14% is a decimal. 0.14. Now, just a reminder, if you're like, now, how's that work again? If you're not sure, you can take any percent, divide it by 100, and it'll give you the decimal form that you need. And we want to see how much this is going to be worth in 10 years. All right, so we have got 2,000, 1 plus 0.14 to the 10th. Let's see. Woo! That's good investment. $7,414. And when we talk about cents, we don't go to all those decimal points. We're just going to round to cents here. That's quite good. Turn 2,000 into over 7,000 that quick. That does not happen very often. Luckily, you're lucky to see 3 or 4%. So, ooh. But you just keep seeing the same setup keeps coming. One more. Jen buys a new car for $18,000. Each year, a car depreciates by 11%. How much will it be worth in 6 years? So let's see here. Started out at 18,000. Okay, it depreciates. Is that going up or down in value? Down. So 1 minus 0.11. And we want to see what it's worth in 6 years. This is going to be scary. And again, I'm just copying what I see. Just remember the caret. Because if you don't put in the caret, it's actually going to come out that it's worth better money, and that's going to be no sense. Ooh. $8,945.66. I like the investment idea better than this. The investment in the business is better than the investment in the car. So, I believe, let me flip back here to the front and see what else we might have left here. I don't think an incredibly whole big bunch here. Because even if you hadn't done the ones that we hadn't done together so far, we've got good examples. Distributing. Just a reminder here one more time, like on a question like 14. If you see parentheses, that exponent distributes to everything.
You multiply it?
You do. You multiply the exponents when you go power to power. Yep. But then don't stop. Yeah, here I've got to subtract my exponents because I still have multiple x's and multiple y's. Yep, 14 minus 4 is 10. It goes on top because the bigger number is 14. Yep, and y to the fourth goes on top because that's where the bigger value is. And if you want to put a 1 there, you can. If you don't, that's okay since it's down there. But those are the type things that we're still working with. And yes, I will still have directions like this, not what I've handwritten, but what I have here to kind of trigger your memory just in case. I think when we got to the next page, let me just make sure. Yeah, we did a lot of problems with negative exponents and flipping, so that was good. Okay, let's just make sure. And then basically when we got back here, we did everything. So just a reminder, when you come in tomorrow, I'll basically just say, hi, how you doing? Then hand you the test to work on for the period. If you need to, go scrambling, looking for notes on things. Hint, hint. The completed notes are even done online. If you've lost something, if you can find a way, get on there, find them, and print them. You can use them, okay? But I won't have extra copies to say, oh, can I use notes? No, you've got to think of this ahead. This needs to be turned in. This is not usable on the test. But any notes that you have, you can use. And like I said, I will give you some directions on there to help as well.